Today we're going to look at applications of law of sines and law of cosines. So our first example, we're looking at a boat that is traveling east parallel to the shoreline, and we need to know the distance from the boat to the shoreline. So in order to use law of sines or law of cosines, we need some information about a side. The only piece of information that we are told is how fast the boat is traveling. So that will give us the horizontal distance here. To find the length of that distance, we figure out how fast it's traveling, which is 10 miles per hour, and then we multiply by how many hours it's been traveling. We were told that it's been traveling for 15 minutes, so we need to convert that to hours by dividing. So 10 times 1/4 gives us 2.5 miles. We also need the distance from the boat to the shore. So I'm going to finish this right triangle here because really this is the side that we're looking for, that we're interested in. And then I'm going to start filling in some of the angles inside the first triangle with all of those dotted lines because that's the triangle that we have the side in. We do not have any of the sides in the right triangle. Up at the top here, on the other side of the right angle formed by the boat and the vertical line, would be the 90 degrees minus 70 degrees, so that gives us a 20-degree angle inside that really skinny triangle. On the other side, we have a 90-degree angle here, plus the 63-degree angle, so that gives us a total angle of 153 degrees. And then using triangle sum theorem, this skinny little angle down here would be 7 degrees. Then we can set up our law of sines to solve for, I'm going to solve for the hypotenuse in the right triangle so that we can use SOHCAHTOA to find the distance. I'll call this x, that is across from the 153-degree angle. So we have x over the sine of 153 degrees equals, and then we know the 2.5 miles, and that is across from the 7-degree angle. Multiplying both sides by the sine of 153 degrees, gives us about 9.313 miles for the hypotenuse in the right triangle. Next, we can set up SOHCAHTOA with the 70-degree angle, the side adjacent, which is the distance that we're looking for, and the hypotenuse that we just found. So we have cosine of 70 degrees equals adjacent over hypotenuse. We'll solve for this by multiplying both sides by 9.313, which will give us a distance of the boat to the shoreline of 3.185 miles. Our next example, we're looking for the distance from the pitcher's mound to first base on a softball field. So one thing to remember is that a softball field as well as a baseball field is a diamond shape, and the pitcher's mound is not directly on the line from first to third base. It's back a little bit. So we can't use a right triangle to solve for that distance. We'll have to use law of sines or cosines. We do know that the pitcher's mound is 43 feet from home plate, and home plate to first base is 60 feet. Now there is a right angle at home plate, so when we drew in the line from the pitcher's mound to home plate, we cut that angle in half, so we have a 45-degree angle. The value we're looking for is the distance from the pitcher's mound to first base. We know side angle side, so that will be law of cosines. X will equal the square root of 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. Remember, you can punch all of that into your calculator at once. Just make sure you use parentheses around everything under the radical. And we get a distance of 42.430 feet. Remember to round to the nearest thousandths place, even if that is a 0.